General Physics 1 is brought to you by Physics Classroom. Before we get to start with our lesson, let's have a warm-up. Here are some group of words which are related to our lesson. Tell the word or words that sounds like the given group of words. And now let us discuss the relationships of physical quantities. Let's get started with direct relationships. Relationships of quantities vary. Some quantities increase proportionately to others. Consider a plane flying in a straight line at a constant velocity of 60 meters per second. Table 2.1 lists the position of the plane at various times during a 5-second interval. The graph of distance versus time is a straight line shown in figure 2.1. This shows that the dependent variable d varies directly with the independent variable t. This means that if the time is doubled, the change in position is also doubled. The relationship of the two variables, shown in the graph, can be written using the proportionality symbol alpha, as distance d is directly proportional to time t, or using the equality symbol, with a constant of proportionality, denoted by k. Thus, d equals kt, and the constant proportionality of k, as k equals d, over t. In general, for any two physical quantities, x as the independent variable, and y as the dependent variable, having a direct relationship, x and y increase proportionately, the graph is a straight line. The quotient of the two quantities is a constant, k equals y over x. Next is inverse relationships. When one quantity increases and the other decreases, there is another type of relationship exist. Consider the relationship between pressure and volume of a fixed amount of gas, shown in table 2.2. The graph of pressure versus volume is a curved line known as hyperbola, as shown in figure 2.2. This shows that the dependent variable V varies inversely with the independent variable P. This means that if the pressure is doubled, the volume will be reduced to 1/2 of its original volume. The relationship of the two variables, shown in the graph, can be written using the proportionality symbol alpha, as volume V is inversely proportional to pressure P, or using the equality symbol, with a constant of proportionality, denoted by K. Thus, V equals K over P, and the constant proportionality of K, as K equals V times P. In general, for any two physical quantities, x as the independent variable, and y as the dependent variable, having an inverse relationship, when x increases and y decreases proportionately, the graph is a hyperbola. The product of the two quantities is a constant, k equals yx. Direct square relationships. In a direct relationship, quantities increase proportionately. In some cases, you can see that one quantity increases more than the other. Consider the dependence of distance on time, as shown in table 2.3a, and likewise, the distance versus the square of time, shown in table 2.3b. In figure 2.3a, the graph of distance versus time is a curved line known as a parabola. This shows that the two quantities are not directly proportional. The graph of distance versus the square of time is a straight line shown in figure 2.3b. This shows that the dependent variable d varies directly with the square of the independent variable t squared. The relationship of the two variables d and t squared is called a direct relationship. Thus, d is directly proportional to t squared, or d equals kt squared, and the constant proportionality of k equals d over t squared. Another type of relationship is called inverse square. In general, for any two physical quantities, x as the independent variable, and y as the dependent variable, having inverse square relationship, x increases as y decreases. The graph is a hyperbola. The product of the two quantities is a constant, k equals yx squared, or y is inversely proportional to x squared. Just like in the inverse relationship, the graph is a hyperbola. And for a brief assessment of learning for this lesson, let's try this. If G and all the other given quantities in the equation are constant, what relationship exists between each pair of the quantities given below from the above given equation?